And we'll talk about solving a system of linear equations using the graph. So graph the equations to find the point of intersection. So algebraically set the equations equal, and that's graphically, and then algebraically set the equations equal to each other and solve for x. Substitute the x value back into one of the equations to solve for y. Okay, so we have, I think I got this all on the screen. So we're going to graph, find the points of intersection of these. H of t equals 3t minus 4 and j of t equals 5 minus t. Find it graphically and algebraically. So graphically for h, it goes through 4, or negative 4 I should say, and it has a slope of 3, so up 3 over 1. Gives us some nice points to work with. The problem with graphically, and I can do this by hand, is if it's not a pretty obvious one where it crosses out a whole number, you're doing some guessing. 5 minus t, so think of that as goes through 5, has a slope of negative 1. Yeah, this looks like it's not going to cross at a regular nice point. So it'd be helpful if I could draw it on top of it too. Okay. So this is our j of t. This is the h of t. So it looks like the x value is somewhere around here, like 2 1/3, maybe 2.25. I'm not sure. And then the y value is somewhere around here, like 2.7 maybe. Okay, so I'm going to go algebraically. 3t minus 4 equals 5 minus t. Now they use t, by the way, instead of x, but same. You could change it to an x if it helps. I'm going to add 4 to both sides, and I'm going to add t to both sides. Oh, t, not 4. So that's 4t equals 9, and divide by 4. T equals 9/4, which is 2.25. Wow, that was a pretty good guess on my part. Okay, for hand drawing. And then we can put this into either of the two. You get the same answer from either because this is where they are coincident. So j, I'm going to do the easier one. J of 2.25 equals 5 minus 2.25, which is going to be 2.75. That's, not a bad guess on my end. 2.25, comma, 2.75 is a solution. Now, I'm going to go ahead and pull up Desmos here because I think there's some value in showing you that tool. Okay, so we had h of t. This is so easy to use. It's a great tool. Oh, come on. I just said it was easy to use, but I made it look not easy. Equals 3t minus 4. There's the line. And the other one was j of t. No. J of t. No. If I can hit the right buttons on the keyboard, it helps. Equals 5 minus t. Now look at that. There's the crossing point. And it tells us the x value is 2.25 and the y value is 2.75. That's how quick and easy Desmos is. Almost feels like we're cheating, but we're not. We were told you to graph it. So there is a graphing utility that's available to you. Okay, so I'm going to come back to here. A company sells sports helmets. The company incurs a one-time fixed cost of $250,000. Each helmet costs $120 to produce, and they sell for $140. So find the cost function. So for our first one, I should have said ABC instead of 1, 2, 3, but whatever. C of X is going to be 120 times X. It's $120 per helmet plus the $250,000 to start up. And then find the revenue function without just how much you make by selling them. R of X is 140X. So they're only making $20 a helmet. And then it says find the break-even point, the point of intersection of the two graphs. So I'll just set them equal to each other. When is revenue of 140x equal to the cost, which is 120x plus 250,000? So we can subtract 120x from both sides. And we have 20x, let me scroll up to give myself more space, equals 250,000. Dividing both sides by 20. X is what? So it looks like it's 12,500 helmets is the break-even point. Okay, so there you go.